We're told that a bouncing ball is dropped from a height of 9 feet, and it bounces up 2/3 of the previous distance on each bounce. And we're asked for the total distance the ball has traveled after bouncing 10 times. It's best to consider this problem using a diagram. After first being dropped, the ball falls 9 feet to the floor. On the first bounce, the ball bounces up 2/3 of 9 feet, which is 6 feet. The ball now falls 6 feet to the floor again. After it hits the floor, it will bounce up again. This is the second bounce. On the second bounce, it will bounce up 2/3 of 6 feet. The ball will continue this pattern as shown in the diagram. We're asked the total distance the ball has traveled after bouncing 10 times. What they mean here is the total distance traveled right at the 10th bounce. This is shown by the green path on the diagram. The total distance can be calculated starting with the initial 9-foot drop shown in purple. We can calculate the rest of the distance using the sum of a series. Each term of the series will consist of the upward motion after each bounce. We see there are 9 terms, so we'll call the sum S9. The first term will be 6 for 6 feet. The second term will be 2/3 of 6, and each consecutive term will be 2/3 of the previous term, until the 9th term is reached. After each bounce, the ball must go up and come down, so the total distance traveled after each bounce is 2 times the value of the term for that bounce. Looking at the diagram, you can see the first term is 6, but on the first bounce, the ball travels up 6 feet and down 6 feet, or 2 times the value of the first term. Therefore, to get the total distance traveled in the green path, we multiply the sum of the series S9 by 2. So the equation we can use for the total distance traveled by the ball after bouncing 10 times is 9 plus 2 times the sum of the series S9. Now we'll have a closer look at this series represented by each upward motion in the green path. These are shown by the green segments on the diagram. There are 9 terms in this series, so n equals 9. The first term of the series, A1, is 6. Each bounce it bounces up 2/3 of the distance of the previous bounce, so the common ratio R is equal to 2/3. The sum of this series S9 will be the total distance represented by these green segments. Each green segment represents how far the ball travels upward after each bounce. We'll start with the formula for the sum of a geometric series. We'll put in 9 for each n in the formula, 6 for A1, and 2/3 for each r in the formula. 2/3 to the power 9 is approximately 0.02600123, and 1 minus 2/3 is equal to 1/3. 1 minus 0.02600123 divided by 1/3 works out to approximately 2.9219631. And multiplying this by 6 comes out to approximately 17.53. So we can state that the sum S9 is equal to 17.53. We had determined earlier that the total distance traveled by the ball is 9 plus 2 times S9. We'll put in 17.53 for the sum S9. 9 plus 2 times 17.53 works out to 44.06. So we can state that the total distance traveled by the ball after bouncing 10 times is approximately 44.06 feet.